Hello everyone and welcome to today's webinar, a part of Intland's Functional Safety Summer Academy. This session today is titled FMEA and Risk Management in Practice, and we'll be covering the topic of risk management and specifically conducting failure mode and effects analysis. So by the end of this webinar, you will know the basics of how to analyze, evaluate, and manage failure modes during development to avoid systematic failures in your product. My name is Christoph Horvat. I work with Intland's marketing team, and I will be your moderator today. And your host during today's session is Adela Beires, Intland Software's functional safety expert. Now, those attending the previous webinar in our Summer Academy series already know her. And if you didn't attend our last one, I strongly recommend that you watch that webinar's recording on the Intland website. But for those that have missed out, let me quickly introduce Intland's functional safety expert. So Adela has worked with successful global companies including Bosch and ThyssenKrupp in the past, and more recently she has spent some time with Automotive, which is a fast-growing, innovative automotive startup that's developing self-driving technology. Now, as our functional safety expert, Adela will be hosting all 4 webinars of Intland's Functional Safety Summer Academy, of which we have 2 more remaining events. Right, so let's start with a quick overview of today's agenda. First up is a brief introduction to failure mode and effects analysis. And after covering the types of FMEA, Adela will talk about FMEA in the context of hazard analysis and risk assessment, and she'll give us a rundown of the FMEA methodology. After this, we'll talk about calculating risk priority numbers and visualizing the overall risk levels of a product. And then finally, Adela is going to show us how FMEA is carried out using Codebeamer ALM. Now, at the end of today's session, we'll have some time for your questions. If we do happen to run out of time, which happens, don't worry, we'll just take it offline and we'll answer your questions via email. So as usual, just feel free to use the questions box on your GoToWebinar control panel anytime during the webinar, and then we'll just review those questions at the end. Today's webinar is recorded, and we will be posting the video recording on our website so that you can watch it again or share it with your team. And so just before we jump into today's session, let me take just a minute to talk about our expert series this summer. So as I said before, today's webinar is actually part of Intland's Functional Safety Summer Academy, which is an expert series of 4 webinars on functional safety. Now, as most of you probably know, Intland's Codebeamer is widely used in safety critical industries with a special focus on the automotive market. And we offer pre-configured templates for our tool with baked-in knowledge and best practices to help these safety critical innovators. And these developers are operating in regulated industries, and so functional safety is obviously a key concern for them, which is why we thought it would be a good idea to set up a series of webinars on this topic to help the functional safety efforts of both current and prospective users of Codebeamer ALM. Again, there are 2 more sessions on the 15th of August and on the 18th of September. So I strongly encourage everyone attending today's webinar to sign up. They're all free, and if you can make it, we'll just send you a recording afterwards. And with that, let me conclude the introduction and pass it on to Adela so that you can start today's session on FMEA.
Thank you very much for the introduction. Welcome, everyone. So my name is Adela Beires, and I'm a functional safety expert in automotive. So today I will talk about FMEA, it's failure modes and effects analysis. After the short theoretical overview of FMEA, I will show you how you can use Codebeamer's ALM tool to conduct this type of analysis and overall risk management. Okay, just a few words about FMEA. It has a long history way back. It was developed by NASA for the Apollo project in 1963. And just over a decade, it was introduced in all major industries. So basically, whenever product quality or safety is relevant, you will do something like FMEA, because it's a very straightforward analysis that will help you just keep all of your requirements at hand and trace the status of them. So it's used from healthcare to automotive, manufacturing, nuclear power plant, pharma industry, etc. Okay, so what is FMEA? As the name stands for Failure Modes and Effects Analysis, it's an inductive bottom-up analysis type. So you start from the root causes of failure mode and trace the effect of this root cause to the top of your system, and then you start to evaluate basically the effect of it. And I will talk about that a little bit later. So as I said, it's a systematic approach, and the goal is to reduce or avoid residual risks. Of course, we know that the sooner you detect any defect in your product or in the manufacturing, you will reduce the development time and costs. So normally you want to start FMEA as soon as possible. Since FMEA starts from the bottom and tries to think what could this root cause on the system level, it might reveal new top level effects, so ones that you didn't think of in the first place. So it's very good. What's a little bit bad about it, that it cannot model dependencies between the failure modes from the same abstraction level, which, for example, a fault tree analysis could do. Okay, so when should we perform an FMEA? Well, whenever you have a new product development or you're changing something in the manufacturing line, you have new processes, or it's just, you say it's a simply a safety-related product development, or you already have a product, but you're changing a part of it, then you might want to do at least some delta analysis to see the impact on the overall system. There are different types of FMEs. For example, there is system FMEA, design FMEA, process FMEA, software FMEA, etc. So they are handling different levels of your system, but they're all using the same approach. So they are starting from defined bottom, and which are then called root causes of the failure modes, and the effect of these root causes are traced back to the defined top level from that particular type of FMEA. What do you need as an input when you're performing an analysis? Well, first you have to define your team. You want to have a moderator for it, which could be an external or internal moderator. It has pros and cons. And then you would need experts from all relevant groups. So for example, if you are conducting a system FMEA, then you would want to have somebody from system design team, and you would want to connect it with some software and hardware experts. Typically, you would need to have bidirectional thinking, traceability, just to check if your inductive thinking was proper or not. Of course, you will need to have system specification and some functional block diagrams, because as I said, you want to start your FMEA from the beginning, so when you're starting your project. So any information that you have at hand will be helpful, because first you have to understand how your system will work. So you need to have kind of a functional chain somewhere, and then you will analyze this functional chain by defining failure modes on each level. If you would perform, let's say, a design FMEA of a hardware, then of course you would need to have already the parts list or hardware parts list. And if you have in your company some defect statistics, they could be very useful when you are evaluating your failure modes. On this level, when you start to define actions, what you want to do with your failure modes, and we'll talk about that a little bit later, of course you would have to have at least a preliminary VMV plan, so verification and validation plan. And if we were talking about manufacturing, then you need to have some process specification. Okay, so what is then the content of an FMEA? Basically, it can be anything. Of course, you want to have your functionality examined, so how it can fail and what effects will it have on your system. But you can also list all non-functional requirements. So you can list some human factors depending on your industry and area that you are using FMEA for. You can list environmental constraints and some legal requirements. So anything that if you are not covering could have an effect on your company and management. So it's a very handy tool to track the status of all your requirements in this way, starting from the bottom and just connecting on the overall system level effect. Just a little bit, let's talk about automotive industry. And as we heard, we had a preliminary previous webinar for the hazard analysis and risk assessment. So if we are in automotive, we will probably have as a first step an item definition, and from that we will perform a HERA analysis, where we will define the safety goals and ASILs for our requirements. So I'm connecting this information because it's a good input for an FMEA. So if I already have my hazard analysis, then I can use this information and put it as a top level requirements for my system when starting performing the analysis itself, so the FMEA. Okay, so what will I do as a next step? I have my functional description, some functional requirements, or I have my hazards and safety goals included. I will do very similar as I did in the HERA. I will take guide words just to be systematic. And on any level I'm performing the FMEA, I will use the same guide words and try to define a proper deviation, so functional deviation, so basically the failure modes. Of course, if I have experience from previous projects, I can use that experience, and I can use some checklists if I have, and overall strategy for the failure mode evaluation. Okay, so an FMEA typically has 3 levels. You can extend it. It depends on the complexity of your system. But normally, you want to have a root cause, so a failure cause, a failure mode, and then top level, you will have the system effect, where you will evaluate actually the impact of your deviation on the overall system. So about the methodology, just a little bit more words. As I said, if you start with the function and you define your failure mode, for example, using the guide words, then as I said, you go to the top and you try to think what this deviation will cause on the top level. You can maybe limitate somehow your effect. It's not always so typical, it's not always at hand. But definitely you will have a severity number. And this number probably will not change, but it will be inherited to the lower levels in your fault tree. So once you have the severity and your failure mode, then what you want to do is actually to avoid or somehow limit the residual risk that this failure mode will cause. So you can try to prevent the failure mode of happening, or you will try to detect if it still happened. For that, we have failure detection mechanisms and preventive mechanisms. I will talk about those a little bit later. But what is important that each failure mode, when we go to the bottom, let's say a system can have 1,000 or a few thousands root causes, depending on your system. But each failure mode will have these 3 parameters. So as I said, the severity value is inherited from the top, and you cannot do much about that. But you can change by different actions the D and O number. Normally, this number starts from 10. So once you define the severity, then you will try to decrease the D and the O numbers by different actions. And once you have those, you will multiply the free values and get the risk priority number, so the RPN number. And this number actually shows the current status of how you're handling this particular risk. Each company or on project level, you can define a level that you want to alarm your management. So for example, you can say that when the RPN number is below 100, so we already got from 1000 to 100, then I say I'm fine, but anything above it should trigger some additional actions, either some additional detection mechanisms, or just you would need a full redesign, or you have to change something in your assembly line, etc. How you are evaluating these three numbers? It's given by standards, for example, NVIDIA standard. So these tables are included also in Codebeamer, but of course you can have your internal company level strategy for it. So I will not go through the tables. They are international ones, so you can find them as well. But basically, as I said, the important thing is that you have a strategy based on what you will decrease these numbers from 10 to something else that you want to work with later on. Okay, so just a few words about the preventive and detection actions. When we are talking about prevention, we think here about preventing a failure mode to occur already, let's say, in a prototype. So, for example, I can use some robust engineering practices. I can connect reviews, simulations, or worst case calculations. And by those information, I can decrease the probability of a failure mode of happening. Most likely, I will not be able to minimize completely this risk, so I will need to have detection actions, which are typically different types of testings. For example, functional testing, lifetime testing of the design, end-of-line testing during manufacturing. Of course, you can have integrated detection mechanisms, which are actually your safety concept. Of course, the testing methods are given in the standards that you are using. So these should be included in your VMV plan. Okay, so as I said before, when you introduce these actions and then you evaluate the numbers, and finally you will be able to calculate the RPN number that will be that will show the status of your current product. What can you do with these numbers? You can make a Pareto analysis. You can show the most important failure modes that were not yet covered, that were partially covered, so your management can have a quick overview of the status. I will show you in the tool how you can actually change here the triggering level for based on the RPN numbers. Okay, so this was the short introduction, theoretical introduction. Now I would like to ask you, if possible, to answer some questions. I will ask them separately. It will take only a few minutes, so just please take a few seconds to answer them, if it's okay. Okay. Maybe just wait a few seconds more. Okay, thank you very much. Let's go to the second one. Okay, thank you very much. The third one. Thank you. Okay, and I promise we have just one last question, and then I will go to the practical demonstration. Okay. Thank you very much. Now let's switch to Codebeamer. Right. So we have here short, small exercise prepared. You see our failure mode tracker, and we have here, let's say, a full tree. Let's check the top level. Failure mode, it says a vehicle does not emit light when required. So if I go here, I can see that I evaluated the severity here as 9. As I said, this is my top level failure mode, and this information of the severity will be inherited to the lower levels. It's very easy to build up the tree in the tool. I can add, I can build it up and I can see it visually what is attached where. So if I go down in this tree, I will come to the root causes. Why don't we have emitting light when it is required? So for example, power supply cable is cut. So if I click on it, I see that the severity was inherited, it's 8. And okay, so what can I do here? I can add my previously listed actions, so preventive actions that will decrease my occurrence number. So I say that we start from 10. Here, based on my actions, I can evaluate how much was the risk reduced, and I can change my number here, and the same I can do with detection actions. When I fill everything in, then basically I click on save, and the RP number will be calculated. So if I say, okay, I wasn't so good, and I change it to 6, save it, I will see that the RP number is automatically recalculated. Let's see what happens if I missed something and I want to add a new failure mode. I just click and say I want to add a new failure mode. Let's say it's just wrong supply. It's just test 4 just to have something written. And when I save it, then I see that it's blank, but the severity was inherited. It comes from the methodology. If for some reason I figure out that I was not correct, so maybe severity should be 9, or my customer said that I should change, then it's very handy that if I do it in one place, I will see that all the requirements that was attached as root causes will have, so they will automatically inherit this new severity value. Okay, so let's go to the newly added failure mode. Since I have my severity, I want to add some actions. So it's very easy. You just start typing. For example, I see I have in my list a simulation. Click on it, I add it, and I can evaluate. For example, if I did this simulation, my occurrence number will be 8. And detection action, for example, start typing system integration test, and I say, okay, with that test, I can decrease my number to 6. Click on save, and so basically I have my first value of my RPN number. I see it's quite big, so it will probably trigger some additional actions. Let's go to the trackers and see how these additional actions are managed. It's now a short list, which could, of course, be extended. It's just an example. So if you're talking about preventive actions, if you list here any new action, when you start to type on the failure modes, they will just pop up. Here I can give the name of it. I can give some hint how much the occurrence number will be reduced. And of course, if you have your VMV plan and you run your testing in Codebeamer, then everything could be linked. And then you would have a real live FMEA. So it will always show you the real status of your product, of your testing, so your current development status, basically. If you do not use Codebeamer in that way, then it still can be a handy tool just to list as a pop-up table your actions. But I recommend that you connect it, and then it's very easy to show to your management or any audit what's your real status and how you are using FMEA. The same goes, of course, to the detection actions. It's very similar. As I said, you just need to connect it with your VMV plan, and it will be a very big list in that case, I assure you. Okay, I want to show you, there is a different view. So if I go back to my failure mode tracker, I can have this table view in Codebeamer, which here could give you a more integrated view. I can put additional columns here. Sorry, just a minute. Okay. So failure mode, I can add here preventive actions, and I can give the detection actions. So this way, you can just run over your whole analysis, and you can see where you have already put some input, where you still need to do it. What I want to show you is that you can actually configure basically everything in the this failure mode tracker. So what's very interesting, for example, you can of course define roles in the project team, and each role can have separate permission. You can define state transitions. So in this particular case, it would mean how you're handling new failure modes. So for example, and you can see basically how your analysis is going on. So you define a new failure mode. You need to plan the actions that we talked about. Then if the actions were taken and you are satisfied, it's verified, then you can close it, or if not, then you have to replan, or you can even reopen your analysis. It's, of course, one example. You can really change it as to adjust it to your company needs. What you can also change is the risk matrix. It's also just one example. Typically, the FMEA is evaluated based on the RPN number, but normally, if you have a high severity failure mode and you see that the RPN number is small, then still you maybe want to take a closer look at it. So even if the RPN number is low and it's highly critical, then maybe you want to just add additional actions just to make sure that you are on the right track. Okay, so when you conducted your, let's say, first iteration, there are lots of failure modes, and you would want to have a more compact view so that you can show it to your management. For that, you go to the TouchWiki page, and here you can show let's say, the critical RPNs. Of course, you can adjust this table to your needs. Here we have a list of failure modes, for example, that were not started to be analyzed yet, so they have a 0 RPN number, or that the RPN number is higher than a certain value. This is a quick overview, and of course, from here you have a link to see the source of this report, where you can actually see separately all the failure modes grouped. So, for example, here and first you see the RPN numbers that are 0, so you know that, okay, you didn't even started to work with these failure modes, and later you have the big RPN numbers, and basically based on this report you can actually define additional necessary actions for the next development iteration. Okay, so this was shortly the practical presentation how you can use the tool. If you have any questions, then please ask them. We're a little bit over time. Let's see.
So far, I see one question. A user is asking what the difference is between system FMEA and software FMEA.
Okay, so system FMEA is typically, so as a system, normally it integrates software and hardware. So you can say that it's if you are developing an item, then you start the analysis from system level. So, for example, you can start with listing the safety goals with ASOs, and you will finish it, let's say, on software architecture level, for example, or on component level from the hardware. The software FME, of course, will not include hardware or high-level system or on the mechanics. So in FMEA, you will list all the technologies you are using for the development of this item. The software is basically using and analyzing the software architecture down to the software units, for example. Okay, are there any more questions?
So the same user is asking whether you have an example for software FMEA issues, as all software is based on hardware.
Sorry, could you repeat it?
Right, so the same user is asking for an example of software FMEA issues. And he's also asking how to separate the software FMEA from system FMEA.
Right. Yeah, it's a tricky question because software really implements the functionality. So when you are conducting, let's say, a hardware design FMEA, then it's straightforward. You start with a high-level functionality, and then from, let's say, component level, you continue doing the same thing, breaking down to the hardware parts, if necessary, if you're doing it in that in such detail. Software is not something that you will want to mix. So software FMEA, on one hand, looks very similar to the system, because if you start to define the functionality of a software architecture, then on high level you will see very similar things as in your system from functional point of view. So the difference is that you will not start listing some mechanical issues or hardware failure issues.
Okay, Adela, there's another user asking whether it is possible in Codebeamer to track the risks in a project without the FMEA theory, so only using the risk tracker.
Yeah, yes. So Codebeamer could be adjusted to basically any needs you have in the company. It could be applied to basically all of the standards, and if you don't want to use it for FMEA, then you can use it, for example, for requirements management, concluding it with testing and reporting back your results to the management. So it's absolutely possible.
And there's another question somewhat related to this one. A user is asking whether FMEA is included in the current version of Codebeamer ALM. I know they answered this one. Yes, it is. So 9.2 is able to handle risk management and FMEA. Okay, we're a little bit over time, so unless there are any more questions, I think we should conclude today's session. But also, please remember that we're happy to answer any of your questions. Just reach out to us at sales@intland.com with your questions, and we'll do our best to answer them all. Right. Well, thanks then, everyone, for your attention today, and we hope to see you next time. Thank you.
Goodbye.
Thanks, Adela. Goodbye.
Thanks. Bye.